Yes.
Okay, so let's talk about Knight's new EndoFlate GI flexible endoscope leak tester. Going to take you on a pre-filled tour. This is not the finished product, so a few things are going to change. If you look on the default display, you can see it does keep the time and the date. Right now it says Knight LLC, but we're going to change that to EndoFlate GI. A couple of little housekeeping issues will change. To operate the system, like most any other leak tester, you're going to have a leak tester tube, and of course the manufacturer's ETO valve connector. This one here happens to be for an Olympus. So once you're connected, I'll take this one off of here, I'll put her on the duodenoscope we have here, push it down and twist it on. Of course, the technician is going to start the test on top of the counter, and all I need to do is hit start. Now, if you can hear the air pump that's in the box charging the flexible endoscope liner, you can see now that on the very top it's giving the technician the instruction to press start to end the leak test. Of course, at this point we're not ready to do that. We're only 20 seconds in and we haven't even submerged yet. But we can see that our pressure in PSI is holding pretty steady at about 3.18, 3.2 PSI. So that's a good indication that our scope is leak-free, at least at this point. Over on the right we can see our counter. That's counting down how long we've actually been doing the leak test, and our little progress bar across the bottom is just a graphical display of whether or not we're stable with our pressure. Okay, so at this point we're gonna remove the OK to submerge message here, just because we don't want to be the device that determines whether or not it's okay to submerge. If the number for PSI or millimeters of mercury or bars is drifting, then we'll show you how that looks when we're going in and out of the sort of the quiescent stable state. When we're in the green, that means that our air pump is fully inflated and holding stable. If it changes from green to blue, that means that the air pump is charging. If it changes to red and gives you a low pressure alert, that means that we're not able to fully pressurize the scope and there's a significant leak. So at this point, if I'm the technician, I've been trained, I know I've got a stable pressure, the display is green, I can now take the scope and fully submerge it into the sink. Once I do that and I go through, I do a full inspection over the scope, I'm looking for my bubbles, I don't see any. Okay, that particular scope does pass the leak test and I can begin my manual cleaning. And to disconnect and end the leak test, all they have to do is press the start button again, and you'll hear a little psst sound. That's the three-way valve relieving the internal pressure of the inflation on the scope. Okay, and now we've finished. So to give you a little further background on what our device is about, I think it's important that you reference a similar device, and that is the handheld leak tester. This one is made by a company called Zutron Medical, and very similar to a lot of other handheld leak testers that are made by Pentax, and Olympus has got them, and a number of other companies. And basically it's an inflation bulb, and by mechanical manual action I can inflate the lumens in the scope. I overinflated there. I got to bring it down a little bit so you can see the gauge. And by inflating this pressure bulb, now I'm looking at the gauge, and my device is telling me I've got to hold steady within the green for a period of 2 minutes. And that basically tells me that that endoscope is leak-free, or at least to a point where I can clean it and the interior mechanisms within the scope won't be damaged. All we're doing with this device is mimicking this operation with a higher level of precision, but basically giving them, a method of inflating the scope without having to do all this manual pumping. Okay, and also prompts the technician through the testing People like gadgetry, so having a display, nice user interface, I think is going to attract some people, but it's easier to use and a little bit, like I said, a little bit more precise. It'll give you the numeric values. And when people see, those kinds of display elements, I think they believe more that the device is more precise, and they're just getting a better overall test. So that's really the general philosophy behind our EndoFlate. It's an inflator. It's not a leak tester. I have to bring a lot of emphasis to that, because this is not to be sold as a pass-fail device. The pass and fail test is the technician's visual indication or visual identification of air bubbles that might be coming out of the scope. We'll get into that a little bit more in a minute, but it's important to make the comparison between these two devices. Now, something like this is sold on the open market for about $200. So when customers learn that a device like this sells for roughly $600, maybe less, depending on what markets we go into, I think we're going to get some good traction. So let's just talk about how you program the EndoFlate GI. Hold the enter key down until the screen color changes, and you've got the normal enter passcode, change passcode entries that we see in most of our products. Here you can select whether you want the digital readout to be in US pounds per square inch, or in European bars, or millimeters of mercury. We're going to, for this demonstration, run in PSI. On this next display selection, you can choose whether or not you want your user to see the pressure, to show the timer counting up, indicating how much time they've been doing the test. In a lot of cases, practitioners will dictate their procedure to have a time element. So as you see on this device, they want you to hold pressure for 2 minutes. You'll find that in a lot of places they want you to test for at least 30 seconds, maybe for a minute. It just depends, but at least by having that visual display, you can see how long the test went on. Okay, to make those changes, you first have to hit the arrow button to get the cursor in the top position, so you can hit scroll to leave it as a yes or no, and just go right on down the list and make your choices accordingly. Hit enter when you're done. Here you can change your time and your date. At this point, this is where you want to set your minimum and maximum pressure values. Now, most of the manufacturers, we're talking about Olympus, Fujinon, and Pentax, their publicized minimum and maximum inflation pressures are between 2.7 and 4 psi. Now, we've got to double check what those values are. But right now, those are the numbers that we're going to ask you to program to, unless you've got another reference to the original manufacturer's inflation values. But right now, based on the best information we have from those companies, the minimum is 2.7, the maximum is 4.0. The typical endoscope is going to be able to sustain an inflation pressure far higher than what the pump in here can produce, so we don't have to worry about damaging the liner in the scope. But it's a general reference. That's what you're going to get out of the box. Now you can change what that range is. I can't advise you right now on any other sources of information for what that should be, but we'll keep everybody informed and have in the instruction manual any references from the OEMs about what these levels should be for setting in the field, beyond what we put in at the factory. Okay? To make the changes, again, you just hit scroll, and you can go up and down. Very simple. Hit enter when you've got the values that you want. Okay? Now the next thing we need to do is we need to calibrate our pressure transducer. The system has a digital pressure transducer built into it that is actually taking the pressure reading based on the back pressure produced when we connect to our ETO valve. Now, when you do a pressure calibration, you're going to use a pressure gauge pressure gauge that would look something like this one. Although from the factory, again, you're not going to have to do this, but in some countries or in some hospitals, they may require that a pressure calibration be done either semi-annually or an annual basis, in which somebody in the engineering department, or perhaps they want to send the unit back to us for a factory recalibration. This is the way that it would be done. So I'm going to take a tube that has the same connector on it as our leak test kit. I'm going to plug it in. On the other end of it, I've got a gauge. Well, it looks like that. And I'm going to hit the start button. And you can see the needle rise and fall. And I can see that right now my valve on the other end is open. I just happen to have a valve here I'm going to use for another demonstration here in a minute. I'm going to close that off to simulate a deadhead condition. And you can see now that my needle is stable, and I'm at about 3.3 psi. So that's what I'm going to enter here. I just hit the up button until I get to 3.3. Hit enter, and now the system depressurizes and holds that value. Okay? Right now I'm going to walk you through one of the settings that may or may not be in the factory version of the EndoFlate GI. Now, we're going to leave this setting here. I want to explain to you how it works and what it's there for. You know, an air leak in an endoscope or in any inflated diameter can be very, very small. Granted, I'm learning about this myself, but you would be surprised how much a single bubble, how large a space that single bubble of air can fill. From the factory, the way we're going to calibrate these initially is going to be at a leak rate of 0.10 psi per second. Okay, now that's a very small leak, but a leak nonetheless. A leak is a leak if it allows air into the liner of the scope. You know, we all know there's a lot of sensitive equipment within the liner and the outside covering of that endoscope. So it's important that we keep the moisture out. So we're going to be able to detect a very small leak at that setting, and our air pump can more than compensate for a leak that small and completely pressurize the inside bore of the scope and the liner to keep water out if they want to continue to clean and leave the air pump on. So keep that number in your mind. We're going to leave it at 10 psi, or excuse me, 1/10 psi per second. Hit enter. Okay, and now we're going to test what that looks like. So press start to begin the system leak rate test. Sorry, wrong button. Hit start. And the system is now testing the inflation, in this case, of this tubing loop, right, and all the connections and the interior tubing that's used between the pump and the pressure transducer, and it's telling us that we currently have a leak rate of 0.02 psi per second, or well below what our setting is. Now, if by turning this needle valve, create a larger leak, and that's very easy to do by opening this needle valve. We'll go back around, I'll show you what that can look like when you simulate a real leak. Okay? So we're charging this diameter again. Hopefully I've got the needle valve opened far enough, and if I hold it under the water, you can see what that leak I've created looks like. Right now, the system is telling me that I've got a leak rate of 0.05 psi per second. And you can see I'm making bubbles at a fairly reasonable rate. The technicians who are looking at the endoscope liners as they're manipulating the controls, I mean, they're trained to find one bubble. So that would be a pretty good leak. All right, so we have a lot of precision built into this instrument, maybe more than what we need, but it wasn't a whole lot of work to give us this level of precision and performance. So, I mean, I can reduce that amount of leak by turning the knob here and closing off that diameter, and you can see I'm slowing the leak down. I can go back around and show you that same test again. See what the difference is. We were at 0.05. I was measuring. Now we're 0.04, so not a big change, but again, still a leak. Okay? And with that kind of a setting, you're going to be fine. At least that's what we believe, using that factory setting. And you know, any scope that's got a minimal leak will probably look something like that. All right, but we're going to develop some hard data to put into the instruction manual, so you have some real numbers to work with. Or, you know, we may just cover this up entirely and there's a factory default that nobody ever has to worry about. We're just not that far down the path. But hopefully at this point, with the prototypes that you're going to have, you'll have that ability to adjust if we need it in the field to conduct our field tests. But that's how that all works. Okay. Okay, so just to finish up that little segment on leak rate testing, I'm going to go ahead and connect it to a scope, and let's see if we've got a leak here. I don't think we do because I've checked it already, but let's have a look. So I'm going to press start. We're pressurizing the liner on the scope. If we look at the distal tip, somewhere in here, over here, I'll bring it over here, David, so we can see it better. We can see that it's inflated. I can feel the difference over here. And the leak rate it's showing me is 0.03 psi per second now. That's holding really well. Okay, so the leak rate is very, very small, if any, and that may be the tubing connections here and not having anything to do with the scope, but clearly the scope sheath and the liner is not compromised in any way, and we're in good shape to finish processing the scope. Hit enter here, get out.